Hello, my name is Emma DeVeydt, and my project is assessing I3S to collect individual photo ID recapture information of gray treefrogs. So researchers use recapture data in order to add higher quality data to their research. So a few techniques that they can use are toe clipping, microchipping, pit tagging, and elastomer injections, although these can be kind of invasive. So we're looking at some photo identification software that'll allow us to do the same kind of thing. So a few that are accessible to us are I3S, WildAD, and Amphident. So we used I3S for this project, which I3S stands for Interactive Individual Identification System, and it's a software that allows us to individually ID an animal species, which in our case it's gray treefrogs. It is free to download, and it can work for many different kinds of species, so sea turtles, whale flukes, grouper, salamanders, and many more, but it's still being tested out for which species it can really be used for. And then the specific application that we used was I3S Pattern Plus, which is another version of I3S. And there's many more, but this is the one that we used. So a few objectives from our research is to assess I3S's ability for matching gray treefrogs and to collect recapture data using a less invasive technique. So this is my study sites. It's the same as Jacob and Kenzie's, except we were able to do all of them. So we had an extra private property and Beaver Dam State Park. So the Piperfugia were checked every 3 to 4 weeks, and there were 2 rounds conducted total. And then the pictures were taken of the back, the right thigh, and the left thigh. So with the back, we would just gently lay the frog down against a white sheet of paper, and one of us would take a picture while the other one's holding it. And then the right thigh would just be gently stretched out. We'd take pictures of the back of the right thigh and then do the same thing with the left thigh. So we found a few different things that we should be doing to get these photos for the software. So pictures need to be taken perpendicular to the subject. We needed to avoid debris on the subject, any wrinkles in the skin, glares, flash, and then we need to be as close as possible to the subject. Make sure that it's in focus, and then before we put the tree frog back, we need to make sure the picture quality is good to go. So once we got all the photos, I had to go through each type of photos to the back, the right leg, and the left leg, and choose the best photo out of all of them based off of quality. They were all then organized within Google Photos through albums, and they were labeled by their date, the transect, and the name of the person taking the photo. All of the chosen photos were then rotated right side up and cropped in order to be used for the software. And then they were also downloaded as JPEG files, which is what the software uses. So the first picture here is showing before cropping, rotating the photo, and then the next picture is when it's all nice and cropped, and you can kind of tell how much clearer it gets just by doing that. So these are the steps to finding a match using I3S Pattern Plus. Into the red ovals, the red oval indicates the pattern that was examined by I3S Pattern Plus. We did try the backs within the software, but it just wasn't working because tree frogs can actually change color, and they don't have as high contrasting colorations. And we also have the pictures for the left legs, but we just haven't had enough time to insert it into the database. So first we have to annotate each and every pattern of the tree frog. So we do this by putting reference points onto the tree frog pattern. So going left to right, we start off with the left edge of the pattern, and then the top middle of the pattern, and then the right crease of the leg. And this is going to be telling the software where it needs to be looking on this pattern to really be able to get full use out of it. And then we also can outline the pattern with the green lines you see there. And again, this is telling the software where it needs to be looking. And then we also need to identify which pattern is which. So we have to put all of the blue X's on the black pattern, and then the red X's on the bright yellow pattern. So then once we finish annotating, I3S is automatically going to put in 35 key points on each pattern, and this is going to act as a fingerprint for each tree frog. So, and then I3S is going to be able to use this fingerprint and be able to like compare it to all the other fingerprints within the database and be able to see if there's a match. And then this is also the segmentation at 0% transparency. So, and this is kind of unique to the Pattern Plus application. It allows us to make sure that we have the full pattern that we're looking for. And then we can also, before searching for a match, we can insert metadata. So metadata is just information that provides insight to our original data. So I can input the ID number, which is basically like the name of the frog. I can put in the transect, the site, and like the photo type. And when I conducted searches, I would filter them using the site. That way there we're not making sure we're not getting frogs from miles away. So then once we conduct a search, it will give me 50 results, and so 1 through 50, and then the lower the score, the better. So the lowest score is going to be at the number 1 ranking. And then once we choose a tree frog that we might think is a match, we can compare their point clouds. So this is basically overlaying the 2 fingerprints of the 2 frogs that we're comparing. So the red circles are the unknown individual, and the blue are is the individual already in the I3S database that we're comparing it to. And then we can also compare the patterns side by side just to see for ourselves if they do match up. And so this is an example of a matched tree frog that we got. This is tree frog number 13. And the top row is from round 1, and then the bottom row is from round 2. So the middle pictures are the right legs, but just by using the left legs and the backs, we're kind of able to verify that this is indeed a match. So my results, for round 1, I had 31 captures, and then for round 2, we got 32 captures. And then out of comparing like round 2 to round 1, I got 5 matched tree frogs, and all 5 of them actually ranked number 1 to their match, which sometimes they can actually rank higher. So you could have a match that ranks like number 10, and that would be telling us that the system isn't really working for this individual or this species maybe. But luckily, they're all ranking number 1. So 15.6% of tree frogs were recaptured for round 2. So this chart, these are the average scores of new individuals compared to tree frogs with matches from round 2 for the first and second ranks. So basically, it's the tree frogs with matches generally have lower scores for ranks 1 and 2 compared to tree frogs without a match. And then this, these are the average scores of matched tree frogs filtered without metadata and filtered with study site metadata. And this is from round 2 for the first and second ranks. And this is basically telling us when a search was conducted with metadata, the second rank for a matched tree frog was generally higher, which means it had a more accurate result compared to the second rank without metadata. So a few conclusions. So I3S Pattern Plus was able to successfully match Gray Treefrogs. A few keys to using I3S Pattern Plus was to make sure your species has distinctive markings, contrasting colorations, and good photo quality, and you're using good photo quality. And then if you look at the pictures, it kind of shows you how much the backs can change. That's just one tree frog that we recaught, and it was totally brown and changed to like full green. And the matched tree frogs generally had lower scores for ranks 1 and 2 compared to new individuals. And then using metadata can help achieve more accurate results. And then some future research, which we kind of started on but didn't have enough time to keep going with it, is to look at the variability between users' annotations. So like in a long-term study, if you have multiple people annotating these images, what is the accuracy for your annotations? And my acknowledgements, so I have Justin Shu as my mentor, Jacob Decker and Mackenzie Williams helped me gather a lot of my data, and then NSFREU for funding and NGRREC for funding, and then there was IDNR, Nicole, Philip, Jennifer, Sage, and then the developers of i3S. Any questions?
Did you kiss that frog?
No.
Sorry if I missed it at the start, but how much of this was automated when you go to set up your images? Like, did you have to put those blue and red crosses?
Yeah.
Or does that automatically do that?
So basically, I just put I have to have like the cropped image in there, and then I'm like doing it all. And then, so the red and the blue X's is, like, once you put in enough of those, it should automatically kind of like give you that segmentation that you saw.
So it kind of doesn't matter exactly where you put them, you just need to put it in the 2 different colors.
Yeah, the 2 different colors, and make sure you get like different variants of that color. So if you have like a lighter yellow color and a brighter yellow color, but like it needs to be all included.
And these guys don't change their color over time and stuff?
Not with, like, I haven't seen anything with the back of their legs, but I think more research probably needs to be done with that.
But do they have that color pretty soon after they metamorphose?
Wait,
after they, from a tadpole, do they start to get that color in their legs pretty
Oh,
quickly?
I did not look that up, but these were all like, I'd say like juvenile to adult tree frogs, because they were all like found in the woods too, so.
That's cool. I don't
Yeah.
When you're in the field, like taking pictures, how long does it take you to get a good picture?
I would say like, maybe like 5 to 10 minutes. And I think too, like it can vary, like the weather, like so if it's, and like where you're at, so if it's like a super bright sunny area and you're trying to take a picture of a slimy tree frog, like it's not gonna turn out as good because there's gonna be like more glares. But even sometimes if it's like overcast, you're still like trying to just get the right angle for the, like, to not get a glare. But it wasn't too long for us. But
like trying to hold the frog on mosquitoes.
oh yeah,
Not
yeah.
the most ideal.
Yes.
So you would have to do this whole photo matching process on both ends to determine, like, you know, the first time you went out and the second time to determine if it was a recapture. How long did it take you, like, you know, putting the photos into the software to like get the results of figuring out whether or not there was a match of it being a recapture?
Yeah, so for like, I did time it. Once you have like all the photos kind of like organized and cropped, it takes about like 6 hours to annotate about like 63 frogs. So to annotate and to see if they have a match or not. Yes.
How would you ensure that the subjects didn't have any debris on them?
We can just like look. Sometimes there's like a little like speck of like mud on them or something. You can just like wipe it off. But yes.
And I know this is probably denoted by what the score was, it was closer to 1, but what exactly is the accuracy rate in believing if it's a recapture or not? Like the confidence, is it like 90%? Is there any sort of information on that?
I'm trying to think. So it's just, yeah, I mean, I guess it's like the lower the score, the better. It all kind of, I guess, varies per species as well. I think too, that was the main kind of part of this project, is to see if it does work with our species. And as long as they're ranking in like the top 5% of the tree frogs, so it gives you 50 results. As long as it's in like those first 5, that's pretty good. That's telling you it's like working pretty well.
So a false positive is not possible?
Wait, what was your question?
A false positive that you think it's?
Oh no, that is definitely possible. But so because it'll spit out 50, and then you can like look yourself and see if it matches for yourself. It ultimately comes down to you figuring out if it's a match or not. And you can do that just by comparing the patterns. And then you can also use the left leg, if you haven't already put it into the database, to kind of verify if you just match up the left legs together. Yes.
How does it do, like, I'm just picturing like some of your pictures, especially at the start. I mean, you said to take it perpendicular, but did it really struggle to like figure it out whenever it was sort of at an angle where, you know, the...
Yeah, it's not, because there was that, I don't know if I touched on it. We had one where it was a really bad angle and it struggled a lot, but I was still able to, this one. I didn't go through these, but that's like a blurry picture, a bad glare, and then that angle is, you definitely don't want that. That was like probably the worst angle we had, but I think I was still able to sort of use it. It was able to pick up the pattern, but I would say it's not as accurate as you would want it to be. Yes?
So with this programming, like, the color doesn't matter as much as the base pattern, right? Because I saw that it had groupers, and groupers, they can change color, right?
So groupers, that would be for like another type of application that you can use. So they have like i3s Classic, they have Contour for whale flukes, they have i3s Spot, they have a bunch of different types of applications. So I would say this wouldn't, i3s Pattern Plus would not be a good candidate for a grouper. Is that it?